In the last lesson, you just learned how to find the vertical asymptotes, horizontal asymptote, or a slant asymptote. Today, we are going to apply all those three concepts to try to graph a rational function. Let's look at the first example. Graph f of x is equal to 4x over x squared minus 4. I'm preparing 6 steps here so you can follow. First step, determine the y-intercept. To determine the y-intercept, you let x be 0, so it becomes 4 times 0 over 0 squared minus 4. That is 0 over negative 4, and that equals 0, so the y-intercept is the point 0, 0. Determine the x-intercepts. To find the x-intercept, you let the function be 0. You could make 0, 0 over 1, then do cross multiplication. 4x times 1 is 4x. 0 times that whole expression, x squared minus 4, will just give you 0. Divide both sides by 4. That will get us x is equal to 0. So the x-intercept, there's only one, and that is the point 0, 0. Identify the vertical asymptotes. To find the vertical asymptotes, you follow 2 steps. First, try to factor the numerator and denominator. See if there's any common factor. Cancel the common factor, then you let the denominator be 0. So to factor this one, I can only factor the denominator as x plus 2 and x minus 2. I don't see any common factors, so I'm going to proceed with letting the denominator be 0. That means x plus 2 is equal to 0, or x minus 2 is equal to 0. That means x is equal to negative 2, or x is equal to 2. Make sure that you write the whole equation, x is equal to, because we are describing 2 vertical lines. Number 4, identify the horizontal asymptote or slant asymptote. You can only have one or the other. If there is a horizontal asymptote, determine whether the function crosses it and at what point. So to see if there's a horizontal asymptote, you look at the degrees of the numerator and denominator. So looking at 4x over x squared minus 4, the degree of the numerator, we call it n, is equal to 1 because the only term that we have here is 4 to the x power, and 4 times x, and that's understood as 4 to the first power. And then the degree of the denominator is 2 because it has an x squared as the highest exponent. So because the degree of the numerator is less than the degree of the denominator, therefore, the horizontal asymptote would be the line y is equal to 0. This right here is the horizontal asymptote. Okay, if there's already a horizontal asymptote, there cannot be a slant asymptote. So we're going to continue with determining whether the function is going to cross the horizontal asymptote and at what point. To do that, we are going to let the function equals the constant that is in the horizontal asymptote here. So it's equal to 0. I get the 0 from there. Again, we can do cross multiplication. We will have 4x is equal to 0. Divide both sides by 4. We get x is equal to 0. So x is equal to 0. That is the x-coordinate of the point where the graph will cross the horizontal asymptote. Now, we do need to provide a whole order pair to complete the description of that point. So the x-coordinate would be 0 and the y-coordinate would also be 0 because remember, we let the function to be 0. So we're going to answer here that yes, the graph crosses the horizontal asymptote at the point 0, 0. Okay, step 5. We want to test points on intervals determined by the x-intercepts and the vertical asymptotes. So to determine these intervals, first we are going to plot these numbers on the x-axis. So here's the x-axis, here's the y-axis. The x-intercept, there's only one, which is a point 0, 0. And then the vertical asymptotes, there are two lines, x is equal to -2 and x is equal to 2. Here's -2, and here's 2. I'm going to go ahead and draw the vertical line through those x values. And I'm going to make it a dotted line because it shouldn't be part of the graph. It's just to help determine the shape of the graph. So here's the other vertical line going right through the value x is equal to 2. Again, dotted line. Okay, so let's mark these points. So now step 5 says test points on intervals determined by the x-intercepts. So what I see here is 1, 2, 3, 4 intervals. So with those 4 intervals, you are going to write -infinity to -2, and then -2, 0, and then the next number is 2, and then 2 all the way to infinity. So we're actually going to create a table. And we are going to pick the values within this interval, within each interval. So from -infinity to -2, just pick any random number in that range. I'm just going to pick x is equal to -3. Now I want to know if I plug into the function, will I get a positive answer or a negative answer? So we're looking at 4 times -3 over -3 squared minus 4. So this will equal -12 over 9 minus 4, which is 5. So this is a negative number. So we're going to conclude anything you pick in that interval is going to be a negative y value. Okay, next we have between -2 to 0, pick a random number. Let's say I want to pick x is equal to -1. Substitute -1 in for the original function. So we have 4 times -1 over -1 squared minus 4. Now that's going to give us -4 over 1 minus 4 is -3, which equals 4 over 3. Now this is a positive number, so keep that in mind. The next interval between 0 to 2, pick 1. So let's say x is equal to 1. We're looking at 4 times 1 over 1 squared minus 4. That's 4 over -3. That's definitely a negative answer. And then last but not least, the interval between 2 to infinity. Let's pick 3. So we have 4 times 3 over 3 squared minus 4. That's 12 over 9 minus 4 is 5. That's definitely a positive value. So what does that tell us? Let me erase all these highlights. Okay, so now it's telling you that the interval between -infinity to -2, the graph is going to be negative. What it means is the graph is going to be below the x-axis. So it's going to be in this area here. And then between -2 to 0, as you can see, the answer is positive down here. So that means the graph will be above the x-axis. Here is between -2 to 0. I'm going to put a 0 here. Okay, between 0 to 2, the answer is negative. So we are going to highlight anything that is below the x-axis, that is between 0 to 2. So it's right here. That's where the graph should land. And then next, we have 2 to infinity, and the answer is positive. So again, it's going to be above the horizontal line or the horizontal axis. Okay, next, let's sketch the graph. So we know that this is the x and y-intercept, actually, the point 0, 0, which we found earlier. So that means the graph would cross through to that point. It will cross through this way because we want the graph to land in that pink section and the yellow section that I highlighted. So it's going to look like this. And we also want the end behavior of that curve to travel along those vertical asymptotes. Okay, next we're going to have this section here. So we know it's going to be below, and given that the vertical asymptote is this line right here, is the line x is equal to -2, but also the x-axis is the horizontal asymptote, because the equation for the horizontal asymptote, we found it up here. It is y is equal to 0, which is the x-axis. And we determined that we already determined it will only cross at the point 0, 0, which we already did it here. So it cannot cross through here at all. So therefore, the graph will look like this. There are multiple reasons why it can't cross over. One is we already determined that the graph has to be below the x-axis. Two is we determined that the graph will only cross the horizontal asymptote at the point 0, 0, but nowhere else. So therefore, it has to stay strictly below that x-axis. Next, that last pink section here, so very similar. We are going to draw a curve where one end will travel along that vertical asymptote, x is equal to 2. And then on the other side, it's going to just kind of travel along the line, the x-axis actually, or the line y is equal to 0. And there you have the graph of the function.